And then we're going to take a look at reliability, one of the measurement concepts. We're going to take a look at a very basic concept of reliability, the true score versus the measured score, and then take a look at different ways to assess the reliability of a particular measure. All right. So reliability. We're now going to go into measuring concepts. And measuring concepts are very important because one of the things that we do as psychologists is we try to measure things, right? We try to measure how good somebody's memory is. We try to measure how confident are they for remembering a word. We try to measure what is your level of depression. We try to measure what is your IQ. We try to measure how resilient are you to challenges in your life. We try to measure a lot of things, a lot of variables. And one of the issues with psychology is that a lot of the things we measure, they're unobservable. And we have to kind of go around, things to measure them. So unlike a physicist who, if they're measuring the weight of an object, can actually measure the weight of the object. You can actually put it on a scale and measure the weight. I don't have a scale like that for depression. So I can't put you on a scale and read exactly how depressed you are, right? We have to use other measures to try to figure out how depressed you are. So that's where things like reliability come into play. So for a particular variable, you have, for anything you're trying to measure, you have a true score, an actual true score. And that is the real score on the variable. So if you are measuring my height, there's an actual true score. There's an actual height that I am. That's what you're trying to get to. If I'm measuring somebody's level of depression, there's an actual real level of depression that they're at. There's an actual real amount of depression that they have that I'm trying to measure. That's your true score, the real score on a variable. That's contrasted to the measured score. The measured score is, not surprisingly, the measured score on the variable. The measured score is the only score you have access to. It's the only score that you know. The true score is what you want to know. And reliability has to do with the relationship between the measured score and the true score. So again, we only have access to the measured score. We want to know what the true score is, but those two are completely different things. So for example, this individual right here has a certain amount of depression. His true score on depression might be 87, right? That's how much depression he has. And if we had some magic ability to look right inside this person's mind and say, where's their depression? Oh, there's their depression. How much does he have? 87. That would be a way of getting to the true score. That's how much depression this individual actually has. What we have is the measured score. So we can say, all right, that's the true score, but that's unknown to us. We don't have that magic ability to look in there. His measured score on a depression scale is 87. So that's the measured score. That's what we have access to. What we want to know is the true score. And a lot of the concepts that we're going to talk about today have to do with the relationship between this score and that score, your measured score and your true score. All right, so that's the first thing that you want to get rock solid on. There's a true score, the real score on a variable. There's the measured score, the score that we were able to get. And because those two are often different, you have what's known as measurement error. And your measured error is your measured score minus your true score. So in this case, we have a measured score of 87. We have a measured score of 83. We have a true score of 87. So there is very little measurement error. If, on the other hand, our measured score was 43 and the true score was 87, in that case, we have very large measurement error. So it's very clear that we want our measurement error to be as small as possible because a smaller measurement error means that your measured score is close to the true score. A large measurement error means that your measured score is very far away from your true score and really tells you nothing about what's really going on. So far, so good? All right. So your measurement error is your measurement score minus your true score. And the basis of reliability is that the smaller your measurement error, the higher your reliability. So the smaller the differences between your measure score and the true score, the more reliable your score is. The more your score is truly a measure of the true score, the closer it is to actually measuring the real thing that you actually want to measure. So we want small measurement scores, we want that high reliability. So to just kind of give you an indication of why that is the case, why we want the high reliability, why it means that we're getting closer to that true score, we'll set up this here. So we'll take a look at a high reliability measure and a low reliability measure. The bullseye here is the true score, and each target hit with the green circles, that's your measured score. So this is the score that you're trying to get. And you can think of every single time you apply a measurement scale to a psychological variable, it's almost like you're throwing a dart and you're trying to hit the bullseye. So I give somebody a depression scale, they fill it out. That's like me trying to throw a dart at their true depression score, and will I hit the bullseye? Well, for low reliability, you have high measurement error. So you might have one that ends up there. There's your second measure. There's your third measure. There's your fourth measure. There's your fifth measure. There's your sixth measure. So you might get close. And we got 7, 8, 9, 10. It seems like 10 is something I would do. All right, so 10. So this is low reliability. And you can see that often you're getting scores that are measured but are way different from your true score. And that's not what you want. You don't want low reliability because you want these to be as close to the center here as possible. If we had a test with high reliability, that means by definition that measurement error is small, which means that our first measured score is right there. Our second measured score is right there. Third is right there. There's my fourth. Fifth, sixth, seventh, 8, 9, 10. So in this case, every single time we measure the variable, we can be very confident that we're close. We're close to the actual true score. In this case, it's very hit or miss. So if we can determine that our test or our scale, our measurement tool has high reliability, that lets us know that it's actually measuring the true underlying variable and it's getting close to it, because that's the only way to get high reliability. If you have low reliability, then you know that your measure is hit or miss. Sometimes it'll get close, but sometimes it'll be far away, and that means that your measurement error could be rather high. So we're looking for that high reliability measures. So we're looking for high reliability measures, but we don't know what the true score actually is. So how do we know when we're close? Well, psychologists have come up with a number of different ways to assess whether reliability is high, to assess whether or not your measurement errors are low. So we're going to take a look at those right now, starting off with test-retest reliability. So test-retest reliability is where you measure the same individual at 2 different points in time. So you give them a test in September, and then you give them a retest in October, and you see how much their scores may have changed. Similar scores on a test-retest reliability measure indicate high reliability. So let's go back to the bullseyes to see what that looks like. So if you have a score, a measure that has low reliability, you test an individual in September, that's their score right there. You test them again in October, that's their score right there. There's a huge difference between these 2 scores, and the only way you can get a huge test-retest difference is if you're nowhere near the bullseye. You're nowhere near the true score. So this large test-retest difference indicates that you are far from the actual true score. On the other hand, if you had high reliability, there's your test in September, there's your test in October, very little difference between the test and the retest. Only way that occurs is when you're close to the true score. So this test-retest reliability is a way of indicating whether you have high reliability, and again, high reliability is a way of indicating that your measurement error is small, that you're close to that true score. Now, for all of these measures of reliability, there's going to be issues and cons and pros to using them. You have a question?
Yeah. So if they were the two green circles were close together, but they were away from the bullseye, that would still be low reliability.
If they were close together but away from the bullseye, you would have high measurement error, but you would end up with high reliability.
Okay.
But what that means is that not that your measurement error for this is, let me say this correctly, it's not that your measurement error is large, is that you're measuring the wrong thing. So the only way that you can have a tight grouping of measurements is if your reliability is high. If you're off the center, if you're off the bullseye, that means that you're not measuring what you think you're measuring. So you're measuring something incredibly reliably, but it's not what you think it is. And that gets into validity. So that's like the second half of what we're looking at today. Mm-hmm. Any other questions or comments? All right. So let's take a look at another way of assessing reliability. So we have internal consistency reliability. And internal consistency and reliability is when you measure the same individual, but you measure them at one point in time. So once again, small measurement error similar scores equals high reliability. And what they often do on this, there's different ways of measuring internal consistency reliability, but you basically give somebody a measure and then you split the items in that measure between two groups, and you compare their scores on the two groups. Okay, so if you have, for example, a 50-question depression scale, then you would split it 25 questions here, what is their depression? 25 questions over here, what is their depression? And then you would compare those two scores. And again, if you get very similar scores, that means that your test is measuring things highly reliable. So they have all these different ways of measuring reliability, because sometimes you can't retest an individual, right? So for example, the individual might be gone. Maybe you're testing students and you're testing them in the semester and they graduate and they're gone. You can't retest them. Sometimes test-retest doesn't work with things that are expected to change. So you could imagine the reliability of a tape measure would be pretty low on test-retest because people get taller as they grow. So it would be unfair to say, well, my measuring tape is a very poor, has very poor reliability because I measured my nephew when they were 4 and they were 58 inches. Now I measured them when they're 6 and they're 68 inches. What happened? My measurement tool sucks. It doesn't. It's just that it's not set up for that. So in those cases, you could use internal consistency reliability, where you take a look at one point in time and you compare the measured items versus the measured items. And again, similar scores equals high reliability. So once again, we have the measured scores. Now we have the green and the yellow. So we split them up into two different groups. And if we had low reliability, that might be where we have the green scores. That might be where we have the yellow scores. And if you compare where the green scores are, so if you compare like their center of mass right about there to the center of mass of the yellow scores right about there, you'll see that when you compare the averages, they're very far apart. Large difference, low reliability, because we're missing that true score with our measurement items. On the other hand, if you have high reliability, there's your 5 green items from the score, there's your 5 yellow items from the score. You take the center of mass, very close together, very small difference between those two sets of scores, indicates once again high reliability. The only way to get this is if everything is close to the true score. Bless you. All right, so that's another way to assess reliability. We got one more for reliability, and that's inter-rater reliability. This one is often used when you have when you do an observational research, when you're having observers look at behavior, and you want to make sure that your measure is highly reliable. So you'll give two observers the same assignment, and then you just afterwards compare how close they are on their observations. So for the work that I do, where we take a look at visual metaphors in comic book art, I will use inter-rater reliability all the time. So I will take, 3 comic books. My research assistant will take the same 3 comic books. We'll analyze it using the measures that we've developed. And one of us will be rater 1, one of us will be rater 2. And if we have similar scores, if we come back and we say, oh yeah, 80% of these images used metaphors, what did you find? Oh, I also found 80% used metaphors. That indicates that our test, again, is highly reliable. So just one more time with the bullseyes. Low reliability, if that is rater number 1 and that is rater number 2, and there's a large difference between their measures of the same true score, again, that large difference can only happen if you're missing the true score, if your measurement error is high, meaning that you have low reliability. On the other hand, if that's the score that I came up with, and that's the score that my research assistant came up with, very small difference here can only happen when the measurement error is very small and both points are close to that true score. All right, so that was reliability. 3 measures for assessing reliability depending upon the circumstances of your measure. Any questions on that before we go to construct validity? All right, so very good question was asked before. What if all these groups are close together but they're somewhere over here? Wouldn't you still have a high reliability score? And the truth is, yes, you would still have a high reliability score, because remember, we don't know where this true score actually is. We can only assess the differences between our measured scores. So all these measures of reliability are based on how different are these 2 measured scores. But there's still a possibility that we are totally missing what we think we're measuring, and in truth, we're somewhere over here, closely clustered, high reliability, but measuring something else. So how do we know that we're actually measuring what it is that we think we're measuring? And that's where we get into validity.